how you even begin to A, find those people, and B, clean up after that type of devastation. Thank you, Kyung. Meantime, tsunami warnings issued for the entire U.S. West Coast now. John Rundle is a seismologist and professor at UC Davis. He's also the founder of the earthquake research group, openhazards.com, and he joins us live from Santa Fe again this morning. And again, we did confirm, in fact, by the USGS that a 4.6 quake did hit in Hawaii as well.
Yes. There's expected to be earthquakes in many locations around the world, and of course, some of them are likely associated with this major earthquake, and some of them would have occurred anyway. So, earthquakes can strike essentially without warning, and this one basically did. I'm not aware of any foreshocks that occurred prior to it that were recognized. Japan in particular is a place where the earthquakes of seismicity roughly occurs at 10 times the rate that you see in California and the U.S. You know, in the Northridge earthquake, one of the interesting things back in '94 in that earthquake, that was a magnitude 6.7, the largest and most destructive one to strike, the most destructive one anyway, to strike Southern California in a couple of decades. Many of the steel-reinforced buildings in downtown Los Angeles suffered damage to their steel structures, steel I-beams and whatnot, the joints cracked and so forth. And that wasn't apparent until earthquake engineers began taking apart the buildings, basically looking to see what had happened. So even for buildings like in places like Tokyo and Sendai that may have appeared to stand up following this earthquake, once they start looking at those in some detail, they may find serious structural damage, which might indicate that whole buildings would have to be torn down and essentially rebuilt, adding to the damage and the cost here.
And Mr. Rundle, you used this word just a moment ago, and again to our viewers as we continue to watch these pictures. Again, this is several miles inland, where this wave of water is washing just everything with it in its path. But again, Mr. Rundle on the line with us, a seismologist. So you used this word foreshocks. There were foreshocks apparently leading up to this earthquake off the coast of Japan. Several days they saw several of these foreshocks, if you will. That might not be a term a lot of people are familiar with, but those foreshocks, did those kind of give us an indication that something big was coming?
Well, the problem is foreshocks don't stand up and wave a little flag and say, I'm a foreshock. Essentially, they're earthquakes, just like any other earthquakes. Now, in retrospect, we can go back and look and say, well, these earthquakes occurred in the epicentral region of the large earthquake, and therefore we think they were probably associated with that large earthquake. They were probably an impending precursor, but at the time those foreshocks occurred, that wasn't necessarily apparent. So that's difficult. Foreshocks look like any other earthquakes, and so it's just not clear, when an earthquake, as it's occurring, when a smaller earthquake is just a smaller earthquake, and when it signals that something larger is about to happen.
I want to ask you another question. We're getting, this information from the government about these tsunami arrival times, I guess you could say. But it's important to note that just because they're saying this could these arrival times happen, it doesn't mean that an actual wave is imminent, right? I mean, so we have this breakdown of where they may be coming, including areas around Auckland, New Zealand, all the way into other parts, all the way down to South America. What exactly does it mean for these locales that are getting these warnings about the when a tsunami may come?
Well, just like weather forecasting and weather prediction and so forth, there are computer models that are run routinely in a situation like this to tell you pretty precisely when the wave will hit. The uncertainty, so to speak, is the amplitude of the wave or the size of the wave when it hits the shore. There are a number of things that can affect that. As some of your other guests have said, these waves travel quite rapidly at about 500 miles an hour, about the speed of a jetliner in the open ocean, and they're not very high. They're maybe a couple of feet high. I think somebody said earlier that some of these waves have been actually estimated to be about 3 feet high in the open ocean. That's actually pretty high, to be honest. What happens when these waves get to shore is they slow down. The water gets shallower, so they slow down a lot. the water behind them sort of piles up so that the height of the wave increases rapidly. And so you get this high wave, this high amplitude wave moving fairly slowly onto the shoreline and inland. And that's what you're seeing in these pictures. Those waves in those pictures are traveling, looks to me like 20 or 30 miles an hour. And they look to me like also they're probably, 10, 20 feet high. So that's sort of consistent with this idea. So the computer models tell us precisely, really, when those waves are expected to first hit. What they can't do quite as well is tell you how large they are. We do have this one experience that we know from the geologic record that there was a massive earthquake off Oregon and Washington in 1700 AD, and there was a 4-meter earthquake. It was a magnitude 9 earthquake, by the way, it's estimated. And there were 3 to 4 foot high waves that struck Japan 10 hours later that came from that earthquake. So it's quite possible that the coast of California, Washington, Oregon will see waves of 3 to 4 feet high, as a result of this earthquake.
All right, John Rundle, great to talk to you again. Thanks so much. We'll check in with you again a little bit later.
All right, we're keeping an eye